Hello everyone, so I'm just looking at this drawing I just drew. I made a couple videos of this. One long video will take probably a few days to load, but I'm going to talk a little bit more at length about this, and I'm trying to imagine what's happening here. So I wanted to use some batteries that I had already to extend the range of my existing electric scooter battery. So I have an electric scooter. I have an electric bike and an electric scooter. My electric bike is like, I think it's like 56 volts, and my electric scooter is 66 volts fully charged. But this would work with either system. This can be any voltage, and these batteries can be any voltage, as long as this battery is lower voltage than these. Now, also, this can be multiple batteries in series or parallel, as long as the voltage is lower than this, and these can be multiple batteries in series or parallel. Usually these are all placed in parallel on this side, and this side is all usually in series. But depending on what you want your voltage to be, okay, that's what determines what you'll have. So I have 66 volt battery right now on the electric scooter, and I have two 42 volt batteries that I have just from other experiments that I've done in the past. And I thought, well, how can I extend the range of my electric scooter right now? What can I do to extend the range in a simple way, right? Well, I can put solar panels on it, right? We've done that before. We've seen the solar project. That worked very well. What surprised me most was people that couldn't understand how that could work. They're looking at it and just not believing what they're seeing. I even had meters showing how much energy was coming from the solar panels into the battery that were showing the watts going in and the amps, the watts and amps. It was a watts up meter. There was a gentleman who said he was an electrical engineer who was looking at the numbers, and he couldn't believe that the solar panels were producing that much power. Now, they weren't producing, to me, that much power. I think the panels were maybe 100 watts each, and at the moment he was looking at it, I was getting, I think, 80 watts out of each panel. And he just was looking at it and just couldn't believe his eyes. He just couldn't believe it. And I couldn't understand why he was having so much trouble understanding that. So he just, he made a video of the electric scooter at the time, and he just couldn't believe it. Like, he was just so puzzled by that. And I really didn't understand his puzzlement, but I answered any questions he had, and I tried to help him understand, and I told him where he can go to learn more. But as an electrical engineer, I would think he wouldn't have so much struggle understanding that, because it's just simple numbers, right? But I guess he just hadn't thought about doing that before, so maybe that's what surprised him. Now, in this system, I thought, instead of pulling solar panels on the trailer or putting solar panels on the side here, right? And I'd probably run them in parallel, I guess is the way I'd probably do it if I was doing that, is put a panel on each side. Now, I thought, what can I do with batteries, right? Let me see what I can do with batteries. So, like, if you look on the scooter right now, which is the Roadrunner Pro, I was able to fit this battery here. It fits right in here really well. And I think this is called a 9-bop max battery. This is the larger battery. And there's also a smaller one. And I don't recall which scooter that's from, but that's a smaller battery. But it fits right in here on top. Actually, it just fits. So if I run those two 42 volt batteries in series, and then I run the negative wire, I'll run the positive and negative of these two batteries wired in series. The positive and negative will go into a motor controller, which I don't know if I have that out here. Yeah, I have one right here. Here's the motor controller. If you look at this one, let's see if the voltage range looks good. Oh, this says 9 to 60 volts. Okay, well, I think that'll work, right? Because we're going, well, I'll try it. I'll see if it works. I'll see if that works. I'll have to try it. And if it burns out, maybe I'll change the capacitors or something. So, I also thought of possibly running a bunch of these batteries in series as well, these little ones. But I thought, well, this is less... it's just, simpler with one big battery, right? So I'm going to run two 42 volt batteries in series, and that means that the plus of one of the batteries connects to the minus of the other battery, right? And then each battery will have one wire coming out of it. One will have a plus and one will have a minus, and those two wires are going to go to the pulse width modulator input, right? So let's see, I mark these, and this says motor, and this says power, P for power. So the plus will go here, and the minus will go here, and then this is the output right here, right? So on these, this minus from the pulse width modulator is going to go to directly over to the scooter battery, which is down inside here. I'll have to get a couple wires that I'll connect to, right? And ideally, I want to go directly to the cells and not through the battery management system, because I don't want to damage the battery management system with the pulses that may be coming through the motor, right? Because I'm going to have a motor in the positive wire, and depending on what kind of motor that is, even if it's a regular brushed motor, I don't know if if there's like a fluctuation taking place in there, and if that can harm the I don't know if that can harm the well, I guess it wouldn't harm the battery, would it? Because this electric scooter has regenerative braking, and when I hit the brake and those motors are pulsing really hard, pumping a lot of energy into that battery, that's already putting a lot of power into that battery when I slow down. So I have to make sure that I have this voltage low enough before I start using the system. I don't want this to overcharge the battery, especially when I'm slowing down, and that's going to put more energy in the battery, right? I'm going to get the voltage down probably to 60 volts before I even start turning this on to extend the range. So the ideal time to charge this, to let this system run, would be when I'm not riding the scooter. So maybe when I'm sitting at a red light or something, or if I stop for a break to have a sandwich somewhere, and I could just turn my motor controller on. I could just turn it on. That's going to make, and with only one wire going through the motor, one wire, right, the positive, splitting the positive. I think the negative can be split as well. I don't know if you could do this on both sides, if you can put a motor on there as well, and do the same thing, all this stuff. I don't know if that can be done at the same time. That would have to be an experiment. But I do know it can definitely be done with the positive wire or the negative wire, one or the other. And if it could be done with both at the same time, then that's just all the more opportunity to do more things, right? So, because this side potentially could be doing the same exact thing this is, right? And in that case, these alternators or generators here, wired in series or parallel, I would say get the voltage up high. Lots of potential, right? Less current. That's my thoughts. So lots of voltage in series. I wouldn't run voltage regulators. I would just pump the voltage up really high as could be. And then if I ran a generator, a two-wire brushed motor, or a two-wire brushless motor, either way, probably brushless is ideal, but I don't know. Brushed is more common that I see. I've seen computer fans, really big high-powered computer fans, that are a brushless motor that have two wires. And that can be used for something like this, right? But I don't know if it's going to allow enough current to go in there, because those don't take a lot of power. They don't take much to turn anyway. So I want to be able to use a large enough motor, because I'm going to be charging this battery at the rate of powering that motor. And no energy that makes that motor spin is lost. That's a free energy. Whatever's in this line is a free energy. This is a free energy circuit right here. It's called splitting the positive, and I'm calling this a PhD in free energy simplicity, because this is not even needed. This pulse width modulator is not even needed. I'm just using it so I can control when this is charging and how fast it's charging by controlling it. But really what can be done is the negative of this battery can be connected directly to the negative of the battery. That's and I'm saying this strictly as a thought experiment, okay? I'm not telling anybody to do this. I just do a lot of experiments, and I'm sharing experiments that I'm going to be doing. It is critically and urgently important that if anyone ever do any experiments, or even think about doing experiments like this, that these lithium batteries are never overcharged. The voltage can never go past its maximum permitted voltage. I wouldn't even get close to it. Never walk away from a system like this when it's charging. Never walk away from that, especially if it's charging lithium. And then what else? And then watch the temperature of the battery too, because these lithium is not permitted to go beyond a certain amount of temperature, right? So I've done many experiments for many years with these kind of circuits on the bench top and on the workbench, and I'll be doing some with the Roadrunner Pro electric scooter, or my other electric scooters. I have many different scooters soon, because I am interested in extending the range, and I think this is an interesting way to do it, this kind of circuit. So I'm sharing what I'm thinking about with you, and even if I don't do this, I still am happy to have shared my thought experiment with you, because I get excited about ideas, but it doesn't mean I'm going to necessarily do it. This might turn into something else by the time I actually get to doing it. But right now it seems like a good idea, and I got excited about the idea of this, and I thought, let me share this with everyone on the channel, and then if I do it or not, if I do it, I'll share videos of that process, or at least of the final version of it when it's completed. I'll try to make videos of the process as well, but sometimes I just want to focus on what I'm doing. But I've been getting better at sharing the actual journey of going through the steps of what I'm thinking about, and I kind of like doing that too, like what I'm thinking about, how I'm approaching thinking about it, what are the thought process of what I'm doing as I'm going through the process of kind of putting a system together, right? So usually the negative wire can go directly to that negative the negative of the higher voltage batteries can go to the negative of the lower voltage batteries. It is required that there's at least, I think, a 12-volt difference in battery voltage, but this is a good space between here. It's like 18-volt difference, right? This is 84 volts fully charged, 66 fully charged. I think this is called these are called 36 volts nominal fully charged, which would be 72 volts fully charged nominal. That's what they call it, but it's 84 volts actual, meaning that's what the charger would say if I charge those two in series. As well as this one's called 60 volt nominal, but 66 volts on the charger when it's fully charged. But I would not want to turn this on until this was low enough where there's a room to put energy in that battery, right? So I would run this battery down first to about 60 volts probably, and make sure I don't get close to that 66 volts. I would not want to get it close to 66 and then forget about it, and I'm riding around and then I'm overheating the battery or damaging this battery, right? I don't want to do that. I don't want to overheat it. I don't want to overcharge it, because lithium cannot be overcharged. It's very bad for it. It destroys the battery. Overheating or overcharging too high of a voltage also damages it, those two things. So the beautiful thing about the simplicity of this is that whatever's put in this wire right here, and a lot of people don't know this, and I didn't know this until I read it, that how can one wire, how could the positive, just the positive, power that motor? And by powering it that way, I'm not losing any energy. No energy is lost. Whatever it takes to power this goes straight into that battery. The energy it takes to power that motor, every little bit of energy it takes to make this motor spin goes to that battery. So if this motor was free spinning, not connected to these motor generators, or not connected to these generators or alternators, right? I was going to say motor generators. Some, like this generator right here, this motor, if you spin this motor, it'll generate power, right? That's what I was thinking of. So if these were motors spinning, I can actually extract energy from motors if I'm turning them with this motor, right? Because then they become generators. But I would likely put alternators here, or something that's specialized, made to make a high voltage, right? I want high voltage coming from these. That's what I would want. Now, if these were low voltage, I would want to step that voltage up, because I want to charge the batteries. This is just my thought experiment right now. I want to charge batteries with higher voltage. That doesn't mean overcharge them. It just means charging them. The idea I'm thinking of is, can I charge a battery with higher voltage and less current? And would it charge more efficiently that way, faster that way? It's just a thought experiment. And that's just my own process I'm thinking about. But if you want to make these put the exact proper voltage into a battery, you can do that too. If you want these to charge this battery, you can have it voltage regulated to not overcharge that. And that would be a way of protecting the battery, right? So it just stopped charging. But here's the thing, on this kind of circuit, this would keep going, right? So if you want to make this all automatic so it will turn off when it gets to a certain voltage, I don't know how you would do that myself. I don't mind doing it manually with the dial. This will have a dial on it. A pulse width modulator has what's called a potentiometer on one of the sides of it, right? And that dial will turn. That can turn. It can be turned. So one direction will make this motor spin faster, and the other direction will slow it down or stop it, right? So the requirement, though, is that this voltage is higher than this. And if you think of like water, there has to be more pressure on one side so it can flow that way, right? And the water, just like a river, like a water moving, the water is not lost on the path to going to this battery, right? To this, we can call this the ocean maybe. This is like a lake or a river, and the water's flowing over here. And on the way, it's going past this water wheel. This is like a water wheel, right? And it just flows over there, you know. And so when someone says, oh, there's no such thing as free energy, well, that's the, and then people that say that, I'll call people that study more stupid, uneducated, go back to school, all these things. And there's so many ways of making fun of people and picking on people. But the reality is that cosmic energy, virtual particle flux fields, tachyon waves, gravity waves, dark energy, dark matter, there's so many different names for basically the infinite cosmic energy that's everywhere. And all energy is interconnected everywhere, okay, through all universes, throughout our universe and all universes. It's all interconnected. That's my understanding, right? And, you know, so it can feel like, one of the analogies I was thinking of, it's like, how can I say this? It's almost like, it can feel like there's a fear of people, you know, learning too much, right? And then people want to kind of say, no, don't do that. Don't learn that. That's dumb. That's dumb to learn that, right? It's dumb to learn too much. But that doesn't make any sense, right? But it happens. I mean, how many times were the smart kids in school picked on for being smart, right? So in the world, like moving on beyond school, or even in school still, but at higher levels, that can still happen if you're like way far ahead, like, you know. But the thing is that people that know a lot are usually very kind and nice, and you can learn from them. And that's the better way to go. Instead of picking on people, how about getting to know someone and being supportive to their journey? And that's the better way to go, right? And then that could help you too, because then you get to learn. You know, picking on people that know more than you, or that know something that you're afraid to learn or don't want to learn or want to continue ignoring. And especially if there's like a group of people that are all agreeing that something, that learning more is dumb and stupid, so you all agree to like pick on people, and maybe don't agree, you just do it naturally without even agreeing on it. I'll tell you, the better way to go is collaboration, and be open to hearing about different ideas, right? Now, this is different than someone saying, give me your money, invest in my free energy machine. I'm not talking about that right now, okay? Because some people go, be careful what you invest in. I understand all that. Right now, no one's being charged for what I'm sharing here. I'm just sharing this with you. I'm not asking for anything. What I'm asking is to be open to learning, and to stop bullying people and stop picking on people, and use that energy to share this unlimited, expansive creation, right? The laws of creation, the limitless energy everywhere, right? Because energy replenishes itself instantly. So if we used all the energy in the space that is in the palm of my hand right here, right? That energy is enough to power the whole planet in the palm of my hand. There's enough energy in that space to power the planet without end. Why? Because space rejuvenates itself. It re-energizes itself instantly. And that's the way energy actually works. So making fun of perpetual motion machines, making fun of all that, and saying, oh, perpetual motion machine doesn't get its energy from anywhere. No one said that. Everyone says the energy is coming from the environment, the perpetual wheelworks of nature. Tesla said that, right? And many other people said it too. He's not the only one that said that. What we're finding out is that Tesla is standing on the shoulders of giants, right? Tesla learned from many, many other people and shared many other people's work, just like many of us do. We share what we're learning, right? We share what we're learning from others. And that's what Tesla did. So yeah, Tesla also did a lot of invention, he did a lot of things and brought a lot of things to light. But know that many people are involved in this research. Many, many people. I'll make more videos sharing more thoughts. I think I just wanted to clarify the perpetual motion idea. And you know, we will make a video on that. I'll make one right now on the perpetual motion concept. We'll make that right now. Okay, talk to you soon. See you soon in the new video coming up. Okay, bye.